Hey folks, well, we've gone through the basics of arrays and we've had some practice with using loops to walk our way through them and to process the elements of the arrays in different ways. It's pretty obvious that we're going to want to start using functions to operate on our arrays, right? Call a function to fill in the entire array for us. Call a function to print out the array contents for us. Call a function to search the array for a value. Call a function to copy one array into another one. So this will make our life a lot simpler. We just have to go through the syntax for how to declare a function that expects an array as a parameter, and some of the more unusual aspects of passing arrays to functions as parameters. So that's pretty much where I want to go in this session. Then maybe in our next session we can start looking at searching and sorting arrays and see what kind of trouble we can get into there. All right, so again, we've looked at the basics for going through an array using a loop to go through and process each element. So first I want to get into this idea of how we're going to go off and set up a function so it can accept an array as a parameter. Now, if we just say, if we want to pass an array of doubles, we can't just say double ARR by itself. We have to tell the compiler that what I'm expecting is an array, not just a plain old double. However, we'd also like to be able to use the same function to process arrays of lots of different sizes. So if I have a function to search an array, of doubles, let's say, I might want to be able to search an array of 5 elements and search an array of 25 elements and search an array of 50 elements. So when we designate that what we're passing is, or what we're expecting to be passed is an array, we just use the open and closed square brackets, no size designation in there. So we're saying I'm expecting to get an array, but it can be of any size. So here we're expecting an array of doubles of any size. And then that means that we also have to tell the function that for this call, how big an array do I want? Or at least how much of an array do I want to process? So we pass the size as a second parameter. So we can give it an array of any size, but then tell it how much we're dealing with this time around. So that's the basic setup for declaring our parameters in our function definition. Then when we actually go to call the function from our main routine, for instance, we've got some array that we want to pass. And so you call the function, and like passing other variables, all you specify is the name of the array. So this is saying, okay, send my array off to the function to be filled in. And then, of course, since the function expected to get the size as a second parameter, we tell it, okay, this one's an array of 20 elements. So again, in the definition, we use the open and closed square brackets with no size. When we create our array, of course, we have to give a size for the array we're creating. But when we call the function, all we use is the array name. Now, that's the basics of the syntax. One of the behavioral things that you'll discover really quickly is that when we pass an array to a function like this, that function actually has the ability to change the content of the array. So with our other primitive data types, ints and floats and things, when we declared it, when we declared a parameter, if we wanted the function to change the values, we had to stick that ampersand in front to make it pass by reference instead of pass by value. In effect, arrays are always kind of passed by reference. We'll get into the actual mechanics of it a little later in the course, but this does mean that by default the function can change what's inside the array. So we have to be a little bit more careful now that we're passing arrays around and writing our functions. If we don't want to trash the content of the array, we want to be careful with how we're writing our function. Actually, later on we'll also talk about creating or defining our parameters as constants, but we'll get into that another day. So we can go through and pass an array to a function. We can specify that our function expects to receive an array. So let's write a few examples to play with this kind of an idea. So, apologies for the ugly slide. So here we've got a complete program, and we're going to have two functions. One function that fills an array with data, so lets the user provide data for each element of the array, and the second function is going to print the contents of the array. So here we've got our prototype for the fill function, where it's saying, okay, my function's named fill, it's not going to return anything, it's expecting an array of doubles as the first parameter, and the size of the array as the second parameter. And similarly, we'll have a function print that's going to print the content of an array. It expects an array of doubles as the first parameter, and the size of the array as the second parameter. So in our main routine, we'll go ahead and use those. And again, I'm going to assume that in just a moment I'm going to go off and write those. So I'll create my array in the main routine itself. So I'm going to say, okay, well, I'll set some constant aside. My array is going to be of size 50 in this example. And I'll create my array of doubles. So this time I'm calling my array data. And I'm going to pass the array and the size to the two functions, one to fill it in, one to print it out. All right, so I call fill on the data, right, the name of my array, the size of my array, and then that goes off and fills it in with whatever values the user supplies. And once it's done, we'll print it. So again, just call print, pass it the array, and tell it what size we want to use. So for the two functions, again, obviously that profile is going to look the same, void fill, double, I've got an array of doubles and a size. And all I want to do is go through and pretty much just a straightforward for loop like we've been using previously, go through each element of the array and do a cin to get the data. Now, of course, we'd probably also be doing a cout, enter the next data value, and we'd be checking to make sure that the cin didn't fail. But just for the purposes of a kind of quick example of our use here, we've just got our for loop going through each position in the array. So P is the current position. And I'm just saying, okay, well, in the array that you passed me, right, the parameter name here is R. So whatever array you passed me in position P, stick in whatever the user types in. So again, we're just walking through all, in this case, 50 positions of the array, filling in the value that the user types in. And then print is just the exact same idea. We're just going to go through the 50 positions and doing a cout to print it out. Right? So for positions 0 through 49, we're doing a cout of the current position for whatever array we were passed. So again, once we've got past this basic syntax hurdle of how we declare our parameters, it's all pretty straightforward. All right, just a couple more quick examples. Say we wanted to have a function that was going to go through an array and add together all of the elements and return the total at the end. And so again, we're expecting an array of floats in this particular example. We're going to add all of floats in it together and return it. So that's going to be a float as the return type. Again, we need to be passed the size so we know how much to go through and process. And all we're going to do is have start our running total off at 0 and then go through each element and add each element to the running total. Right? So for each position in the array, go through and add whatever in that position to our running total. And then once we get to the end, once we've gone through all the positions, just return it. So again, relatively mechanical. Maybe a slightly more interesting example. Let's have one that's going to copy the contents of one array into another array. So here, our function, we'll call it copy, is going to take two arrays. Right? So here we've got an array of longs. We'll call that our source, the one that we want to copy out of. And the other one, also an array of longs, will be our destination, the one we want to copy into. And then the size, how many elements we want to copy across. Now, one of the things we need to be careful of is that this size isn't too big for either array. Right? If size is bigger than the source, if the size is 50 and the source only has 10 elements, then we're going to be trying to copy elements kind of from off the end of the array, elements that don't actually exist in the array. Similarly, if size is bigger than our destination, then we're going to be trying to write stuff into destination where we've gone off the end of the array, where maybe there's only 10 elements, space for 10 elements in the array, and we're trying to put things in positions 11 and 12 and 13 and whatnot. And the compiler doesn't tell us that we're going off the end of the array. It just lets us trundle happily off. And what will take place is we'll actually be trashing memory just after the end of the destination array in this case. Or in that first example where size was bigger than source, we'd be copying data out of memory that was kind of off the end of our source array. So you do want to make sure that you are careful that your sizes are always within the bounds of the arrays that you're using. So in this example, I'm assuming that our size is okay here, that whoever called copy took a look at the sizes they were using and picked the right size, and then went through and said, okay, well, if we've got a valid size, then we'll simply say for each position from 0 to size -1, we'll copy what's in the source in that position into that position for our destination. So again, we can quite happily go through and copy our elements. Maybe let's set up, let's go through an example where we do our copy, but we'll experiment a little bit with arrays of different sizes and maybe how we set up our call to this correctly. So let's give that a little whirl here. So let's try copier.cpp. Oops. So I'm going to have my copy function here more or less like we set up. Our source array, our destination array, the size that we were expecting, and in my main, let's create two different arrays of longs. Let's have our source is going to be, I don't know, 5 elements, and I'm going to initialize it right here. Let's say 1, 2, 3, 4, 5. Well, let's use different names here. Let's say array 1 and array 2. Let's make array 2, I don't know, 9 elements. Let's say 10, 20, 30, 40, 50, 60, 70, 80, and 90. So we've got our two arrays. We've initialized them right in the declaration here. And let's try a copy from array 1 into array 2. And we'll copy 5 elements, so we'll pick something reasonable this first time around. Maybe we'll have a print function as well to go through and print the contents of an array. So we should implement those two functions, and then we'll play with this a little bit. So let's say for our copy, for positions 0 through size -1, we'll just copy what's in my source in that. Oops, I want to go into the destination, and I want to go from the source. All right, so this should be going through for each of the positions, take what's in the source and copy it into the destination. And then for our print, same idea. For our positions 0 through size -1, we'll just go through and spit out what's in the array in the current position. All right, let's see if we can compile that and find out what kind of syntax errors we've got. Copier.cpp. Oops, and let's stick that in. I don't know, let's use copyx for executable. Yeah, all right. So let's try running our copy. Oops. Actually, let's take a look and see if I remember to do everything I wanted to do there. After we copy, let's print the array 2. And we'll print all 9 elements of array 2. So we're doing our copy and then printing out the whole array 2. So this should have, in theory, our 1, 2, 3, 4, 5 and overrating those first 5 elements, and then the 60, 70, 80, 90 still there for the rest of them. So let's compile again, and we'll run our copyx and see what we get. And yeah, so this is going through doing the print after the copy, so we see the first 5 values were copied across from the first array, and we've got the elements from the second array. All right, now let's see what happens if we give it a bad size here. So this time, let's try and copy 7 elements from array 1 into array 2. So now we're going through and seeing, we're going off the end of array 1 when we're trying to do our copies. So let's compile again and run it again. And so here you see that it copied those first 5 values across, and then for the 6th value it got a 0, and for the 7th value it got this big weird result. So this is where it's wandered off into memory and grabbed things from off of the end of our first array. So this is why we have to be a little careful about our array bounds when we're copying things like this. So when we're doing this, I guess let's throw in a couple of constants here for our 2 array sizes. So size 1 is our 5, size 2 is our 9, and we'll use those. When we're printing, we'll use the constant for that array so we get the right size. But this time, let's go through and when we copy, let's actually stick in a chunk of code to figure out the right size to use. So let's have a size variable that we'll set up here. And we'll take the smaller of those 2 sizes and use that. So if size 1 is less than size 2, actually let's pick a better name, amount to copy. How about that? So if size 1 is less than size 2, our amount to copy is the smaller of the 2 of them, so it's size 1. Otherwise, so if size 2 is less than or equal to size 1, then we'll say the amount to copy is size 2. And we will actually use our amount to copy. So this is just an example of us trying to be careful when we're doing our copy about making sure that we've got a check-in to make sure that we're not picking something that's off the end of either of our arrays. So hopefully, if we do this, oopsie, helps if I get my syntax right. So we've got our integer sizes and our integer amount to copy. Let's try compiling that again. And let's see what my new error is here. Oops, missing a semicolon at the end. All right, that looks a little better. And so hopefully this time it copies an appropriate amount from array 1 into array 2. And that looks a little bit more like it. It's correctly recognized that 5 is the correct size to be using here. So again, that's just an idea of the kinds of things that we wind up doing to make sure that we're sticking safely within our array bounds. And again, we can, you can quite happily experiment with what happens when you go off the ends of the arrays. So let's say for our print function there, instead of printing just the array content, we'll go way off the end and print 20 elements of the array. So we'll see the next 11 next 11 memory positions after the end of the array. And so we will run this thing again. And again, you get the idea. There's the 1 through 90 that we were expecting to see, and then there's a whole bunch of other garbage in here. And one of the things that we noticed, just as an interesting happenstance here, is that there's a 1, 2, 3, 4, 5, which just happens to be the content of the other array. So actually that lets us make a guess that off in memory it's got array 2 stored, and then something else, and then it's got array 1 stored. So again, you can wind up learning all sorts of interesting bits and pieces about what's going on in memory when you're playing with this stuff. All right, I think that was pretty much everything that I wanted to go through for our examples of using arrays as parameters to functions. So where we'll go next time around are some functions to search arrays, to sort arrays, special searching algorithms if we know an array is sorted, maybe a function to go through and check if an array is sorted or not. So those will be the kinds of things we tackle next. All right, until next time.